put you on the spot to introduce IATI and tell us what it is, but if you don't mind.
Yeah, no problem. There's a couple of other deep IATI experts on the call as well, Sylvain and Rolf and a few others. So welcome, folks. IATI is the International Aid Transparency Initiative. It's an open data standard for describing development and humanitarian activities. So at its core, it's a set of metadata around those activities. So who's doing it, where are they doing it, what sectors are they targeting, how much money are they putting towards those activities, what are the results of those activities in terms of impact on human beings. So it's a really comprehensive data standard. It's described in a very technically hierarchical way as an XML, a hierarchical XML data standard, which sort of translates into a relational, can sort of translate into a relational model. But I've also seen it being translated really well into a graph model. One of my former colleagues, a guy called Rory Scott, did a really good Neo4j instance of IATI, which allowed him to map through the delivery chain. So who's funding who to do what, because all of the data set in IATI is produced to the same standard by 1,600 individual publishers. So there's no central sort of, there's a central data store, but all of the individual data sets are generated by the community. So matching them together is really important. I don't know whether Rolf or Sylvain want to add anything on that. Well, back to you, Brent.
Yeah, thank you. And we have some interesting people on the call. Rolf, I warned you that I might call on you just for a minute, but you experimented with Neo4j years ago. Would you like to just share what you did, maybe?
Well, I have to be very modest about it. I installed Neo4j, that's about it. I did a few things with it, but I never got to the level what John was saying, what Rory did, and maybe, I'm not sure Sylvain is on the call as well, so maybe he's been doing that. And yeah, maybe Tom is here as well. I don't know if you introduced yourself already, but I know that Tom tried things with Neo4j and the IATI data in the past as well. So I can't really add a lot of experience at this point. I just have questions.
And I just wanted to add that, Rolf, you did, just your initial experimentation with Neo4j a million years ago, just a little, I think there's a post of yours, but it kind of inspired all of this years later. So thanks to you, this is where it ended up. And Tom, do you want to just introduce yourself for a second? Or Sylvain, maybe?
No, I had to, my mic was off, sorry. Well, I know a couple of you guys already from the network. We are a software company, but originally we originate from international development. I'm an agriculture engineer, and we used, especially I worked a lot in monitoring and evaluation. So to manage those data, but not just the data, but also the, let's say the project logic. So how activities through outputs, etc., contribute eventually to SDGs. So we also modeled that on in a graph. So we are a technology partner of Neo4j since 2016 already. So we have done quite a lot of graph work, and now we are involved with one of the big international NGOs, the CGIR, to do data, but also to use AI and LLMs to, let's say, to create a narrative out of a, let's say, a graph-based knowledge graph, which basically contains the project logic.
Are you optimistic about the future of graph databases in terms of the generative AI age and large language models traversing graph data, Tom? And then I'll let Jennifer share her thoughts on that.
Do you want me to say something about that?
Are you optimistic about it? And then I'd love to hear Jennifer's optimism.
Okay, but we are, let's say, we are doing a, let's say, knowledge graph as let's say, as a way to express knowledge, and links between different items is very powerful. We combine it a lot with vector databases. And fortunately, let's say something that Neo4j recently also added to its project. So we do a lot of what they call RAG, so retrieval augmented generation, that we use and in that one is graph is very powerful, but also in general, let's say if any machine learning pipeline, which basically takes as an input some kind of vector, but those vectors can be a lot richer if they are generated based on graphs. So I'm optimistic, but always, I also see it, there is a tendency of people using graph for anything, but it's also always important to focus on the graphy part of your problem. Because for other, you shouldn't, let's say it's not a solution for anything, so.
Yeah, and Jenna, so we have two guest speakers that are just going to introduce themselves, but before they do, Jennifer, are you optimistic about, AI and large language models traversing Neo4j?
Yeah. So Tom actually covered quite a bit of the ground that I was going to kind of toss out there. So he kind of set this. No, that's all right. You set the stage for me. Thanks. So we're focusing heavily on what he mentioned, RAG, retrieval augmented generation. So basically using the database and the vectors that Neo4j now provides as a foundation to explain the answers that the LLM is giving you, or so to either verify that data is correct or to provide better accurate answers to improve the answer coming back from the LLM. So there's a couple of different kind of routes you can take there. You can just retrieve the data from Neo4j and use the LLM as kind of a natural language wrapper around that, so the results look pretty and are human sensible. Or you can actually just feed that data directly to Neo4j and return that. But either way, you're dealing with kind of vector stores, which help calculate similarities, which LLMs are very good at dealing with and working with. And then you're basically retrieving those results. And you can see that because of the paths in Neo4j, the relationships and the nodes that are stored there, you can see where the LLM is getting the answers or how those answers were come about. A lot of machine learning is very black box. You don't know how it's arriving at the answers that it's giving you. And Neo4j can help provide a way to verify those or improve those answers.
Thank you so much. And real quickly, I wanted to introduce Liz Rigby with the UK's Humanitarian Innovation Hub. And Liz, do you want to just introduce yourself if you don't mind? And you're an organization that's interested in humanitarian applications of AI. And
yeah, absolutely. Hi from me and my toddler, who hopefully will be asleep. She's anyway, childcare issues. So lovely to meet you all. Yes, I'm Liz Rigby. I work as the Communications and Engagement Manager for the UK Humanitarian Innovation Hub. And what we do here at the Hub is we work to solve big sort of humanitarian problems through rigorous research and creative system level innovations. And the way we do this is by convening, collaborating, co-creating, and sort of crowding in resources from both within and outside of the humanitarian sector. So we're just looking at embarking on a new project. And the rationale behind this is that AI is likely to change our world in the coming years, as we all know. And I think from the humanitarian sector, it's important that we navigate a way forward that can kind of assess its potential to strengthen humanitarian practice, but also while mitigating the potential challenges of AI. So yeah, we're working on a new sort of joint initiative with the UK Humanitarian Innovation Hub and with ELRA, and we're looking at this initiative to really support the uptake of AI technologies in the humanitarian sector. So yes, Brent, did you want me to go into a little bit more detail, or?
No, just for right now, I think we're good. I wanted to just get Valentin in, just one last person to introduce here, and then Liz will talk more about your work. Towards the
Okay.
Valentin, do you want to just introduce yourself real quick and what your your vantage point on all this.
Yeah, so hello everyone, and thanks Brent for setting this up. Valentin here from France, nearby Geneva in Annecy, if you get a chance to come. So I'm running a small development agency called Boldcode, where we specialize in privacy by design application development. So we develop various applications for humanitarian or impactful projects. And yeah, of course, very much interested into the cybersecurity side of things, into all that. So we helped a few organizations building products, auditing system, and sometimes responding to incidents. And yeah, looking forward to hear more about Neo4j. We have Glenn in the call, who is our technical director and who knows you a bit. So yeah, thanks for having us, and yeah, we'll be around.
Thank you for joining us. So back to you, Jennifer. You're the star of the show. We so IATI is this amazing open data sharing framework, and it's XML based. And would you like to just share a little bit about loading XML into IATI and maybe challenges?
Sure. Yeah. You want me to switch and show slides?
Yeah, if you'd like to.
Okay. Yeah. Okay. We can just dive on in. Let's see here. Too many tabs open. That's my problem. Okay. I'm just going to share the entire screen here, and then I can move this window over here. Okay. That's much better. All right. So I just kind of put together a few slides to kind of cover the generic map of everything. And then we can absolutely dive deeper, answer questions, and so on as we go along. So just to highlight for me, I'm a Neo4j developer advocate. I mostly work on Java and JVM technologies, although with the Gen AI stuff, I'm kind of branching out and playing with some other things right now as well. But typically that's kind of my wheelhouse. I like speaking at conferences. I write technical blogs, and just kind of overall a geek. Like to read and cook and Star Wars and all that sort of stuff. So variety of different things I like to do on the side, but technical stuff. Okay, so large language models, LLMs. If you've kind of, well, I guess been in aware and in the technical area industry this year, you'll kind of hopefully be familiar at least somewhat with LLMs. Things like ChatGPT and other libraries that are available. ChatGPT is kind of what took the world by storm this year, where users can just type in questions and get answers from these large language models. So the good things about this is you get a very natural language response. There's a lot of broad knowledge because they crawl the internet, and they're trained on tons and tons and tons of data. I watched a really excellent video yesterday morning kind of talking about how LLMs are structured, and there's a variety of different models on how many billions of basically features that they're trained on. Of course, the large ones are anywhere from 70 billion on up. So they crawl the internet, they reduce it down, they compress it and into vectors basically, and then when you run your when you submit questions, it retrieves data that's most relevant or similar to what you have queried. Okay, so pretty cool. It does some amazing things we found out, but there are some downsides too. The negatives: it might not have the latest data. These models are trained. The smallish models, I saw somewhere where they calculated it up, cost you about $2 million over the course of 12 days in order to train these models. And those are the relatively small ones that you can train it on your laptop or smallish libraries. So those are not the big ones. You're talking hundreds of millions of dollars probably on that end of the spectrum. So, but they cut off at a certain data time. So typically 2021, 2022, somewhere around in there, a lot of the models have cut off. So you're missing very recent data, latest news articles, updates and releases for movies, or updates and releases to technology libraries or syntax changes, anything like that, it may not have. And when they're unsure, sometimes you can end up in this hallucination phase with LLMs, where you get kind of estimated answers, or it doesn't know, and so it just kind of throws something random at you. And that can be really, really bad, especially when you're talking humanitarian aid data, right? You don't want it to hallucinate. You're talking lots of money and potentially, politics and world relations and all sorts of things going on there. So I did a little bit of research on the IATA. The API they have is okay. There's lots of data sets, and I've heard that there's already a massive data set sitting there waiting that's in XML. It just really needs translated. But when I was going through and playing with this, I just kind of looked at the different options. You could search for a particular data set if you wanted to, or you could just hit the API. I found the API kind of pulled in a variety of the data sets and kind of built a more graphy model for me. So that's kind of where I leaned. They have a few different subscriptions. There's a free tier available. That's the one I'm sitting on right now, and it wasn't a problem. They have I think up to 10,000 requests a day, and I've had no trouble not hitting that, so I've been fine there. The single flat data sets that I mentioned, that's where you just look at a particular study. They're reasonably flat, not a whole lot of graphy or connected features there. Where you really get into very connected data sets is when you start combining all those data sets and looking at overall pictures. So for instance, participating organizations for the donations, or for the aid that's going out, who's involved, what countries are getting the aid, those sorts of things. When you start piecing those all together, you get a much bigger picture of where the aid is going and who is it helping, and that sort of thing. So I stuck with the API. The API does have a learning curve. Their query params are a little not overly clear. There's lots of single letter variables, and descriptions are helpful, but there's not a whole lot of examples and so on. But anyway, getting all through that, you can retrieve XML, JSON, or CSV responses. Because I knew that this group is dealing a lot with XML, I kind of leaned to the XML side and stayed with that. My opinion, JSON's a little easier to read for me and a little easier to parse, but by all means, the XML is fine, and there are tools out there with Neo4j to make this happen. So I've got an example there on the right-hand side of some XML and what that looks like coming back from the API. And then the link down there at the bottom is their API playground. So you can kind of query and retrieve data and play with query parameters and get different types of data. And that's kind of nice to see what the structure looks like and see what you're dealing with. Okay, so Neo4j. It is what Neo4j terms a lot as schema free, or I like to think of it as schema flexible. You have a schema, but you're not forcing a schema. So if you're familiar with things like relational databases, even document database and so on, you typically will set a schema kind of restriction or query, if you will, that tells the database, this is the structure you need to put data into. And it has to follow that. So when you put data in, if it doesn't follow that schema you've defined, then it kind of errors out and says, nope, we can't do this. The data is not in the right format, or not what we're expecting. So Neo4j will allow you to drop data in, which makes it super flexible. It also makes it very easy to refactor later on. So if your data model changes or new data comes in and you need to add additional entities or relationships, it's very easy to make that transition. You just kind of migrate the data into that new format, and you're off and running again. You'll query the data with Cypher usually. There's some other ways to go about doing that, and there's some things with LLMs that make that a whole lot easier. But typically you write Cypher statements. Neo4j understands Cypher. That's its query language of choice. We do also have a utility library called APOC, awesome procedures on Cypher, which is a library, a utility library of different procedures and functions that do all sorts of wonderful things for manipulating data, cleaning data, transforming data, however you need it. APOC probably has something to help you out. So it's an amazing library. I highly recommend. Then you'll need to still construct cipher statements to create that data according to your model. So even once you get these pieces in place, you have the XML, either from documents or files or from an API or somewhere, you'll need to kind of import that XML. You'll need to construct cipher in order to loop through that and transform that data if needed, and construct the data model, put that data into the model that you have. So to get import, the headers kind of threw me for a loop because the API requires headers on it. You won't have this problem if you're dealing with XML files or an existing XML data set somewhere. But if you're pulling directly from the API, they do require headers on their requests. Our cloud database solution, which is called Aura, blocks procedures that accept headers right now because of security reasons. So you'll have to do something like a local database or some kind of alternate hosting solution and not mess with Neo4j Aura. If you already have the data in file somewhere, you can drop those onto someplace like S3, and you could absolutely retrieve those from Aura. That would not be a problem. It's only if you're dealing directly with the API and you have headers. So APOC here is a lifesaver. When you're dealing with import, it has both an apoc.load.xml as well as the apoc load JSON params, which the JSON params takes the headers coming in off of the API. But again, we're going to stick with that first one, the apoc.load.xml. And that procedure accepts headers as well. So you'll have a URL parameter. You can pass in some sort of like path, basically like an X path, and that second parameter, which I've just left empty. So for expressions and things, and then the headers map there that you can kind of see. And there are two headers that come on. There's a caching and a key header that are on the request and those are the two parameters that I've kind of outlined there. So for more of an overview on the APOC load stuff, there's documentation out there. I've linked that down there at the bottom. It'll also be on the last slide. And there's tons of information out there. There's videos, there's blog posts, there's example code using APOC load procedures. So there's lots of things out there. And of course, if you run into problems, we do have a community forum, or you're welcome to reach out on any kind of community platform you're comfortable with to get those answers. So. Okay, I'm going to check. I heard something pop into the chat here, just to check. Okay, so keep strumming on here. All right, so data import. You'll kind of draft the data model. So looking at the data that's coming in, and that's exactly what I did. I looked at what was coming back from the API playground, and then I also tossed in just an introductory kind of overview query that I could just retrieve the data and just kind of look at what's the structure I'm getting here. How do I want to put this model together? And here's kind of what I came up with very, very briefly. This is not a full out model. I just kind of skimming the data and looking at what I had. So I found that you have activities, and then you have organizations that are participating in those activities. And then those activities are kind of in general sectors. So things like culture, society, that sort of thing. So you can absolutely tweak this model, change this model, do something totally different. You can extend it and put other entities and relationships in there. But again, just kind of an intro model to start with as something small. This kind of shows you have organizations doing activities, and those activities fall within some sort of general sector or industry, if you will. So relationships is where you're going to see this value. You can imagine if you put in lots of different organizations who are participating in lots of different activities in various types of sectors, you could easily see, okay, what are the most popular sectors that have the most activities? Probably things like medical and disaster aid and those sorts of things. But maybe you'd find a surprise in there. Maybe there'd be something pop up that you didn't expect. different organizations, who's donating the most money or participating in the most activities across the board. Maybe what are the biggest organizations that are more a part of? What are your kind of smaller ones? Maybe you want to donate to those smaller individual kind of pop-up organizations rather than the massive ones, or something like that. So there's a variety of things you can do even just with this data model, because you have these relationships to help you understand what's going on. Okay, so here's kind of the outline of the import statement that I constructed. So you'll have the URL and the headers. You will basically unwind or kind of loop through, if you will, a list of the activities that are coming back and their related properties. You'll create each activity node. So there's this thing in Cypher that distinguishes between a create keyword and a merge keyword. Create is basically just a straight insert. It's just going to toss that data in no matter what. But as you might imagine, you could get duplicates out of that because it's just going to insert it without even thinking or checking. Merge actually will go out and try to do a match or a select, if you will, and see if that data is already there with those keys. And if it finds it, then it's not going to do anything with that. It's just going to return that existing entity. But if it doesn't exist yet, it'll go ahead and create it. So merge is typically the way you want to go if you don't want to duplicate data. So in this case, I'm merging each activity node. So that way, if it comes across the same activity, if that data is duplicated somehow in the data set, it's not going to duplicate it in the database and recreate it. Okay, and then once you create those activities, then you take the organizations list that's under each activity, and you'll unwind that list. You'll create or merge, and in our case, each organization node so that you, again, don't have duplicate organizations sitting out there. Then you can create the relationship between the organization to the activity, or vice versa if you want to. Then I took the list of sectors and I unwound those. I merged each sector node, and then I created the relationship between the activity and the sector there. And again, you could tweak that data model, change it all around if you want to. This was just kind of my process for putting the data into the model that I showed on the last slide. So as an example, here's kind of general Cypher. Now, there's a few things I've cut out just for kind of readability. And I'm happy to showcase the entire Cypher statement. It's not super pretty right now. And there's ways that I plan to kind of clean that up and make it more efficient by batching and that sort of thing. But this is just kind of the general outline. You have the URL, you'll call an apoc.load.xml, you'll pass in the headers. That basically yields a value and an object or a row of the XML, if you will. And then you unwind the activities. You'll drop into the children, the list of children tags from the XML. You'll unwind the titles and the descriptions tags within that. And then you call this apoc.merge.node for creating an activity node. And it'll pass in the ID as the identifier property there in that first parameter. And then you'll pass in the text and the description, or excuse me, the title and the description, and save those properties onto the node. That will yield a node back out of that procedure. And so then we can take that node and go on to the next thing. So then you unwind the organization list, you create those entities, or in this case, apoc.merge. So you're going to merge them, and you'll create organization nodes. You'll use the reference ID that's on the XML as the identifier parameter or identifier property, excuse me. And then I just saved the name for now. I didn't add any additional properties. And then you'll pull that node back out of that procedure as well. So yielding the node. And then I create the relationship. So I have my activity node and I have my organization node, and I create the relationship with a merge statement there, which is, let me see if I can pull my, oh, it's not going to show my mouse. Okay, so that's the merge act node participates in, highlighted in green, part node there. So then the next line unwinds the sector list, and it's going to basically do the same thing on the next line for merging the sector nodes. The sector is the label, and I'm going to use the code as the identifier property. I'm going to put the name property, save that onto the node as well. That's going to retrieve the sector node out of that procedure. And then I'm basically going to merge the activity node occurs in, so the sector node occurs in the activity node, and then return everything that I just created. basically. So I have the link down there if you want to know more information about apoc.merge.node, which is the procedure I've used here. Basically, why I did that is so that I can create dynamic labels if I wanted to, or dynamic properties. Standard Cipher does not accept dynamic values. It'll say whatever you have. So it won't accept dynamic values for the label name. It won't accept dynamic values as property names, etc. So what I did here was just use this apoc.merge.node so that I could pop in dynamic values if needed. So that's super helpful. Okay. So let me check if there are any questions before I dive into the okay.
So I think the questions were more around the infrastructure that they're using. Are there any questions that are for Jennifer as part of that?
I just had a quick question about naming preferences. You know, the IATI XML, they have their own naming system, and
Right.
mapping that to Neo4j. You know, it'd be nice if we could have a conversion, in a sense, to kind of standardize a conversion for Neo4j. You're thinking about moving forward, but do you have any thoughts on like naming?
So what I haven't seen a way that you can, well, there probably is a way programmatically you can do this. Basically create like a template file and say, map these tags to this in the Cipher, et cetera. But most of the time when I've done data import, I've just kind of manually mapped it in the Cipher statement, as I was showing kind of in the last slide. But yeah, really just how you map it is how you're organizing that data model. So however, that's why I think creating that data model up front and knowing what the structure you're going to be putting that data into is super valuable, which it is. It's required on things like relational databases and so on, but not as much required on the Neo4j side. But knowing that structure, then you can help map that. And right now it's kind of a manual mapping process. There are some import tools that can map certain things, but I don't know how well they do XML at this point in time. And I did notice, because the IATI has very specific XML structure, like it's not, I won't say it's not standard XML, but there's some XML that look different from the standard, that either creating a template to have it mapped to, or just having to do that manually is probably the better way to go. Because I think trying to use existing libraries and things like that, it probably won't get the mapping quite right. John, did you have a question?
Yeah, Jennifer, thanks. It feels like what you're suggesting is come up with the Neo4j target model first of all, and then map the IATI JSON or XML into that. Does that mean that almost for each use case, you would want to develop a single model? So for example, a use case of doing, I don't know, who's working in what sector in what part of the world is one model, whereas the use case of who's funding who to do what is another model. Would you go down to that, or do you think there's a universal model solution that would be possible?
Everything that I've looked at, I think you can use a universal model. So the model that I had, where it used organizations, activities, and sectors, I think is still super valuable. Now, if I don't think you're going to have a size that's going to out jump that model. If you were dealing with like billions and billions of data points and relationships, you might have to skinny that model down a little bit and focus on one area or the other. But that's also where something like using our Neo4j data science library can help you write projections for retrieving subgraphs and things like that, which that gets into something other that's deeper. But I think that the value really is in putting as much of the model as you can into a single database. So if you have organizations and sectors and activities, and maybe you have countries, and maybe you add fund amounts or fund categories, if you will, and you toss in other things, I think that just enriches your model more. So the different varieties of entities that you can have helps kind of uncover these relationships and these connections in there you may not be able to find by siloing them, if that makes sense. Does that answer your question?
Yeah, it does. That's really helpful, because again, that's maybe a good challenge to the broader community, is can we come up collectively, collaboratively with a single model, which then actually becomes a resource for everybody else. So
yeah, and
that's the next challenge.
Yes. Yeah. And I will stress too that Neo4j being schema free or schema flexible, you don't have to have the entire schema completely mapped out and nailed down from the get-go. You could do exactly what I just did and just start super small and simple, and then start tacking on additional entities as you find that that adds value. So by all means, refactor or add more data in later and really kind of gain the value from that. The nice thing about Neo4j, the schema free, schema optional, is you can just throw data in from the get-go and a general format and go, okay, is this super useful? Is this valuable? And they go, oh yeah, but actually it would be more valuable if we add this. And you can absolutely do that later on. That's the amazing thing about it. Okay, Tom. Tom, did you have a question?
No, sorry, I had a problem unmuting. Yeah, a number of things. Thanks for the explanation. I think for a lot of people it's quite useful. But let's say when it comes to models, of course it's always whether your data set is big or small. Mm-hmm. You have to, let's say, it's basically the use case and the kind of queries that are an important element in deciding what the model you choose.
Sure.
So because for any information system, it's not the value. The value is in what you get out of it, not what you put in it. Right?
Yeah.
So that's one thing, and I think Neo4j as schema flexible, as like Jennifer mentioned, it also allows you the possibility to run several models on top of each other.
Yes.
So you can choose for, let's say, if you want for a certain type of query, you need other types of relationships to exist, then you can superpose them. So that's another thing.
Mm-hmm.
The third thing, and also in the context of AI and LLM, we have quite some good experience with, let's say, extracting a model from an existing graph database, and then adding that to your prompt that you send to GPT. So basically, based on the schema information, you can have even GPT suggest, and it does it quite well, especially since the latest version, to write a cipher statement to answer your question.
Yes.
Yeah. So, and that is especially for those who are not very familiar with cipher. It's a very good start, because then it knows it shows you the power of cipher, but also it helps you to get to results quite quickly.
Yeah, absolutely. And there's a couple of slides that I kind of high level go over that a little bit, what that looks like. So, Sylvan, did you have a question?
Yeah, I think most of them are kind of answered at this point. So it's definitely good to hear. It's first of all basically the data providing of or providing the data to Neo4j. First, at this point, you've done it through connecting to the data store. The data store is very limited in some ways and very powerful in other ways. But would it be beneficial to either try to just load one XML file, or just load all of the XML files separately from storage, or even first convert them to, let's say, JSON and then try to load them?
I mean, that's it kind of, I think, is a toss up. So what I ended up doing initially, and let me pull up my instance here. So I just went with Neo4j Desktop is a local application you can download. It lets you create local databases on your laptop or your system, and then you can load the data in from there. So I've just created an instance, and I did, well, actually, I saved the query over here somewhere. Where is it? There it is. So I started because I was having a few issues dealing with headers and so on. So I just basically went out to the playground, pulled in a single XML file, dropped that into an XML file into the import folder for my database, and then I just tried to load that and return a maximum of 5. So this is the, here, let me zoom in on this so you guys can read this a little better. So this is the values that are coming back. So this is an activity. You can see it's got default currency, a last updated time, which might be super useful as well. And then the children is where the details really are. So you have to loop through all these children. You've got the identifier for each activity. You have a reporting org. Then it has children to get like where that reporting org is or what the name of it is. And then you've got where the information is going, and notice that it also has multiple languages that you can kind of sift through for those values. I ended up just pulling in the English renditions of it, but by all means, you can do a variety of things there. The description, which is again, different languages you could pull in, and then all the participating organizations in a list. So again, this just gives you kind of a good high level. I'm pulling in a single XML doc, one single activity, and looking at the structure for what I need to import. And then I can construct my cipher statement going, okay, I think the data is mostly in this format. So I would recommend kind of dealing with 1 or 2 documents maybe, or small samples of the XML, and getting kind of the structure that you need and putting together the cipher statements that help fit that. And then try running it on a broader scale with more documents and see how that ends up. But just to construct the cipher, sometimes that's a little finicky. So to do that, dealing with a small subset of the data is going to save you a lot of time and kind of hassle. So, and I just pulled it in from a flat file so I wouldn't have to hit the API. And then you could load a variety of documents. If you have a bunch of flat files, you can drop those into an import folder basically and loop through those. Or you can hit, host those up on an API or drop them into a S3 bucket or other type of cloud storage bucket and pull those in from the web. If you are more comfortable and would rather deal in JSON, that's fine too. I think the JSON format, I also have that one, a sample there because I retrieved it as JSON, which is just a parameter in the API. If you're going straight from there, whether to return XML or JSON. And just to get a look at the data here, I didn't end up doing anything with this, but you can see there's fewer tags to loop through here. It would be a little bit more of a direct mapping, but by all means, if you're not comfortable with JSON, don't touch it. So yeah, it's a little bit different in the way it kind of maps things. Okay. Did that answer your question?
Yeah, I think so. It's definitely quite eye-opening to see how you can interact with the files. Personally, we maintain the old IATI data store. There's also a current IATI data store, which are both now based on Solr. And I would definitely, if you're thinking about working with the Neo4j for IATI data, I would definitely recommend using the files. There's a file dump in the chat. And the main reason for that is the loss of relations that happens in the conversion for these data stores. So yeah, it's just a tip for anyone that is thinking about getting started on it.
Okay, great. Daria?
Thank you, Jennifer. I have a question about the time dimension. Like at Neo4j, how can we manage time? Because like in humanitarian response within time, the weights change, the nodes change. So how can we manage that? Thank you.
So are you talking about like importing time into the database itself, right?
Yes.
Okay.
And also managing within time, if weights change, nodes change, how do we monitor storage?
Yeah. So storing time values, basically kind of creating your own time series data data set, if you will, inside Neo4j. There's a few different ways to go about it. There's a few different blog posts out there that'll show you a few different things. But what I might be inclined to do, what I would probably do starting out, what would be my go-to, is to create generic years or probably years, nodes in the data set, and say, okay, these are all the activities that happened in 2023. These are all activities happened in 2022. You're probably going to end up with a lot of data and a lot of relationships going around that node. So then you could end up separating out by month, by a week or day, if you will. Just depends on how detailed you want to get. You can also store dates as part of relationship types. So instead of saying activity occurred in sector, you could say activity, what am I trying to think? Submitted or happened in month and then year. So you can actually create that as the relationship itself, and that helps querying if you're dealing with a lot of entities and a lot of relationships. So we don't, there's not a way really to handle time outside of that. However, you can index properties. So you could query for, for certain dates after a certain point. Like let's say the exchange rate changed today, or the beginning of November 1st. And you could go in and you could index the date property for when a transaction happened and say, okay, for all the transactions occurring after November 1st, pull all those back, update the exchange rate, and then update the new funding value or something like that. So that might be, if you're just doing kind of general broad queries like that or updates like that, it might be easier to just leave it as a property. It's only when you're doing very specific, very detail-oriented date queries when you might want to separate, those dates out a little bit more into part of the model, basically. And then, I'm sorry, remind me of your other part of the question after that.
No, yeah, that was yeah, just
Okay.
how to really monitor or update the weights and like relationships.
Okay, perfect. Let me know if you have questions on that.
Thanks.
Okay. Is there anything else so far? If not, I'll jump back into some slides and just cover a little bit of the retrieval augmented generation piece with LLMs. And then by all means, if you have questions back on previous things, we can jump back. So retrieval augmented generation. This is kind of a component of generative AI where you're usually using a data store or some kind of knowledge store of some sort to validate or help provide more accurate answers to the LLM. So it helps you incorporate recent data. So I mentioned that LLMs aren't often up to the latest and greatest. Helps reduce your hallucinations. You basically then can use the LLM to style the results as natural language. So it still creates a very chat-oriented, very natural feeling of communication, but you're retrieving those results from a data store and then basically using the LLM to format them nicely. You don't have to use the vector capabilities in Neo4j. However, it can help provide even more relevant answers and provide better verification, because basically what you're doing is vectors are taking a wad of text and creating a series of float numbers that represent that text. So most of your LLMs have a way that you can dump text in and it will create an embedding for you, which again is just a list of floats that represent that text. That's a vector. Then you can take that vector and you can store it in Neo4j as a property. And if you have massive amounts of text, think like entire blog posts or documentation files or big news articles or so on, you can chunk that section of text because the LLM will only take I can't remember what the term what it's called, but it'll only take so many bytes or size of text in order to convert that to an embedding.
Tokens is the word that you're looking for.
That's it. Thank you. So yeah, so many tokens, and depending on the model that you're using, they have different token sizes and so on. But if you're dealing with a lot of text that's going to basically be larger than that token amount, you can use Neo4j and chunk that text down into pieces, and then you can submit that over to get vectorized, basically. And there's some examples of people doing that out there. And then, so once you've possibly chunked the data, you've created embeddings from that text, you've stored it in Neo4j as a vector, you can create an index on it, making it very quickly searchable inside the database. So it works like any other index does, helps you find things faster. And then you basically do a similarity search. So you say, hey, I have this prompt coming from the user, vectorize this, go out to the data store, look for the most similar vectors that are most similar to this one, and then retrieve what you have on that. And then you can, of course, when you submit that data that's coming back from the database, you can tweak your prompt or add some more context in the prompt, and then send over the vectored data that you got from the database as well, all over to the LLM, and the LLM will take all of that information and produce a natural language response for that. So you're adding context, the data from the database, you're potentially adding context in your prompt as like background or how the LLM should format it or respond, you know, whether they should be helpful, whether they should only stick to facts or for their means or so on. So you can be as specific as you like there. And there's, you may have seen articles about kind of prompt engineering becoming kind of its own work of art or work of science, if you will. There's a lot you can do around prompt engineering, but that's a separate topic entirely. So there's a couple different things that I've come across. Tomasz, if you haven't seen his blog post, if you're not super familiar in the Neo4j sector, he has written an absolute ton of content that is really excellent on using LLMs and Neo4j and RAG and all sorts of things. So this is one example that he used. He's got news sources that are feeding into an NLP pipeline. I'm starting over on the right-hand side of this pretty picture. And so news sources into an NLP pipeline, that's populating the data into Neo4j. So that's kind of the data import side of things, which probably won't be an issue if you're just putting XML data in there and one and done kind of thing. But then you have a user there on the left-hand side in green that's asking a question to the chatbot app that you can put in front. And that chatbot app is going to send the prompts over to OpenAI or some other LLM. That OpenAI or LLM will generate cipher queries potentially, or give you article summaries, etc. You send those cipher queries over to Neo4j, it retrieves that relevant data. The chatbot app then kind of sends that answer back to the user, the information. So that's one example. Another kind of very, very similar is using the LLM to format that response coming back as well. So you have the user who's sending a prompt or question, if you will, to the chatbot. It generates the cipher statement over to the LLM. It sends the cipher statement back to the chatbot, queries that out to Neo4j, retrieves the results back into the chatbot, drops those database results back out to the LLM, potentially with additional context in the prompt, if you want to add that. That generates the natural text coming back into the chatbot, and then that answer gets sent back to the user there. So this is all retrieval augmented generation. Basically, you're using the LLM in combination with a data store, in this case Neo4j, in order to kind of create this cycle of natural language questions and responses, and pulling valid, concrete data from a data store that you can be sure how it's arriving at that data, because you know what query it's getting sent and what the data is in the database, and you know it's valid results. So when you're dealing with RAG and with vector, you have this user, you pump the user question to the LLM, that gets sent over to Neo4j. you pump the results of Neo4j back over to the LLM, and that gets sent back to the user. That's a general structure, and that's a kind of suggested structure, but by all means, you can tweak that and add other calls out to other agents and things like that too. So you're going to put the data into Neo4j. You'll create embeddings somehow using OpenAI or some other model, and you can just create a call to those models to create the embeddings for the data that you're passing it. You'll save those embeddings as vectors in Neo4j, and of course, then create a vector index for those vectors in the database. The LLM is going to create a vector for the user question. You'll use the Neo4j vector index to find the similar documents to that question, and then you're going to return those similar documents to the user, potentially feeding that over to the LLM first for, natural language results and so on. And there's an example of this architecture by my colleague Adam Cowley, who built an educational chatbot for our Neo4j Graph Academy platform on the Neo4j documentation, making it very easily searchable. User can write a question in the chat, hey, how do I construct a cipher statement like this? And it'll go out to the documentation, find the results that you need, retrieve it back. Or, hey, I don't understand this concept. Explain it to me. And it'll go out to the documentation, retrieve the relevant information, and send that back to the user and help learn alongside. So Neo4j Graph Academy is a really good place to start if you're familiar or if you're not very familiar with kind of large language model or RAG or getting started even with Neo4j. There's 2 new LLM courses out on Neo4j Graph Academy, and I think there's 2 more in the works. I'm not sure when those will be released, but those are all available out there if you just kind of want to start somewhere. The playground for IATA is super useful and helpful to get an idea of what the data looks like coming back. Neo4j APOC is super helpful for loading XML or JSON or other types of data structures. You can create embeddings. There's a link there to the OpenAI doc, so you can absolutely use other LLMs to create the embeddings. This was just one example I've seen pop up a few different ways with OpenAI. More about Neo4j vectors. There's release information. The vector search just came out this summer, I believe. So if you want to look at kind of the high-level details, architecture details, announcement, blogs, and things like that, they're all available out. And just probably Google it or head to Neo4j. But the documentation there is what I've linked here. So how to use the vector indexes. And then some example blog posts that I found super helpful to get started with creating chatbots and adding Neo4j to help provide the context or the knowledge graph behind those. So
that was amazing, Jennifer. I love all the questions.
I know I covered a ton of ground, very high level, but if there's any questions, by all means.
Good. John Adams, would you mind if I ask you for your, are you optimistic about us using Neo4j? And, I think this is something that IATI really needs is, we need to experiment with different databases. And what's your takeaway on this great talk of Jennifer's?
I think it's really good that we've got capabilities like Neo4j around. I think there's so much potential of it. And I really like the potential of the RAG stuff and being able to allow human beings to interact with what is a fairly complex data standard and set of concepts to understand really, as well as just a data standard. So actually having IATI supplemented by RAG could be really useful in making it available to more humans. I think that's probably the vision. But I think there's a shed load of really deep technical work to do to define a canonical model for IATI, get that imported into Neo4j, make that available to a lot of people. So I'm probably looking over to people like Sylvan, who's a whiz at all of this sort of stuff, to sprinkle some magic on it.
And take heart. This field is still really, really new. Yeah. We're all kind of learning at this together. So there's still a lot of details that I myself am not super comfortable with or super confident about. So we're all just kind of going to build things and work through things together. And if there are stumbling blocks, we'll try to reconvene and figure out where we went wrong. But yeah, it's a lot. This is a big industry. It's very complex, but yeah, there's some really amazing things that can come out of it, and things are getting easier all the time. So
yeah, and I think I always keep going back to what's the use case. So what's the question that people are trying to work out? What's the real world question they're really trying to resolve? You know, it's things like, you know, who's funding who and dealing with, you know, health in East Africa type of thing is a really useful question for people. So I know Brent has got some promptathons going on at the moment. So maybe again, if we can use the collective mind of people building the prompts, we can then have Neo4j as a really good representation of a lot of structured, well-organized data, which can then be fronted by prompts going through your RAG as well. So I think that there's ways of making this work, which will make it much easier for humans. And for that, I'm really encouraged. Thank you.
yeah.
Thank you so much. So we're going to actually have some more of these discussions looking forward. Thanks to Yolanda and Jennifer for organizing this trial run that we're having now. And we're looking forward to continuing the discussion. And Liz, we cut you off earlier, but did you want to give one last shout out about the UK Humanitarian Innovation Hub if you're there, or otherwise?
Yeah. Yes. Thank you so much, and thank you, Jennifer. That was so interesting to listen to, and like you said, amazing things can come out of this, and that's why we're really excited about this new initiative, which is going to be called AI Solutions for Humanitarian Challenges, and essentially that's it in a nutshell. We're going to be leading some foundational research, identifying the opportunities, risks, and barriers to AI adoption, and to map the AI landscape. And working with ELRA as well, we're going to be launching a new funding scheme. So that'll be offering seed grants for organizations to carry out rapid problem sort of explorations and develop those design briefs for a chosen sort of problem, if you like, a humanitarian problem that they would like to explore the use of AI to solve. So our role within the hub, what we're going to be doing is bringing together those organizations to work up these challenges, and really kind of get under the skin of what those issues are. And I suppose the overall outcome of that is that it'll then translate into some sort of guidance for humanitarian practitioners, or for the humanitarian sector more broadly, to think a little bit more critically. So really exciting things. It's still in its infancy, but yes, really excited about it.
Thank you so much, Liz. And Yolanda, I'll return the event back to you to close. But thanks everybody for joining us today. It's been amazing.
Yeah, thank you. Really, it's I mean, all the work that you're doing is very important. So thank you for doing that. It's a little bit different also for us, but we really, I mean, appreciate having the opportunity to help you guys. So that's important. I just wanted to say I can share the recording with all of you and make it public if that's okay. Was there anything? And Liz, I just realized maybe I'm not sure your project is public or not, but I could edit also the part that you mentioned if it's not public information. Just want to make sure.
Yeah, it will be by the end of this week. So yes,
Okay.
kind of exclusive here.
Okay, I'll wait a couple of days then.
Lovely, thank you.
But yeah, so I can post actually this video on YouTube and also link, and we'll share also the slides and all the resources, so you can go back to it and find more information. Like Brent was saying, we can definitely, so this was like an experiment to see like how the format and how helpful we can be, but we can do this more often as well. So it will be on the Neo4j channel, or I can also share it with Brent. And we can post it in different places, totally up to you. We can, yes, so if we can put a schedule together. We can talk about it now. We can talk about it you can think about it, whatever is convenient. But I think it would be great to have a regular cadence so we can help you along. I mean, it sounded like we could do like something like a modeling session, maybe, for example, that sounded like something that everybody was having a lot of questions about. So that's totally open. So Brent, I'm giving it back to you because you have to proceed from here.
Yeah, no, it's been great. Yeah, I think we're going to work together some IATI data, and then iterate it through different modeling steps and loading steps. And I think it's really important to the humanitarian community to try to get IATI mapped really well, into a graph database, and then work out, as we mentioned, the naming conventions and things like that. So I think we have our homework ahead of us, but this has been a great start, and we look forward to having another one of these and some regular events. So with that said, thank you, everybody. And I guess I'll close our exciting event. And thank you so much for joining us, everybody. And we'll stay in touch.
Yeah, thank you.
Thank you.
Thank you.
Thanks, everybody. Bye.
Bye.
Thanks. Bye-bye.
Thank you.